Lesson 52, Chemical Mixture Problems. Let's look at this screenshot from the book just to wrap our brains around what we're doing in these problems. I've got two beakers basically. So I have a beaker that's 50% concentration of a certain solution, okay, of a certain ingredient, and that's what I'm starting with. And then I'm going to add something from a second beaker that has a different concentration, let's say 10%. And I'm going to mix them together. I'm going to mix them together so that's what I'm adding, the green. My final solution is going to have a different concentration than either of what I started with. So that's my final solution. These are similar to our coin problems where we have a quantity equation and a value equation. So I'd like us to think back to what we know about the quantity equation. We're going to start with saying I have a certain volume of one solution, and then we'll call that V for volume. And I'm adding some more volume from a second solution. And I end up with a final V. We're going to call it V sub F, V final. Okay, V1 plus V2 equals VF. That's what you're always going to start with. That's my quantity equation. That's like the number of dimes plus the number of nickels is total number of coins. Okay, and then if you remember with our coin problems, we have a value equation, right, where we add money plus money equals money. Only our value here is not money, but it's concentration. The concentration of a certain substance, and we're going to assume that's as a percent. Okay, so right here, in place of, instead of putting like how many cents each thing is worth, we're putting the concentration of the element. We'll subscript the same. So we have C1V1 plus C2V2 equals CFVF. And I think if we can think of these as being similar to our coin problems, it'll really help us. Let's dive right into example 1. A druggist has one solution that is 10% iodine and another that is 50% iodine. How much of each should the druggist use to get 100 milliliters of a mixture that is 20% iodine? Okay, so I'm going to write just my template equations over here just to remind us. All right, we've got a quantity equation, our volume, right? Volume plus volume equals volume. And then we're going to attach the concentration to each volume, each amount. So C1V1 plus C2V2 equals C final V final. Okay, that's just to remind us. Now let's fill in what we know. How about from the first equation, the volumes? Do we know how much, like how many milliliters we're starting with? Read that first sentence. The druggist has one solution and another solution. No, it just tells us about the concentrations. We do not know how much. We don't know the volumes. So just leave those as variables, V1 plus V2. Okay. In fact, read the next sentence. That's exactly what we need to solve for. How much of each? So that's what we're solving for, V1 and V2. How much of each should the druggist use to get 100 milliliters of a mixture that's 20% iodine? Okay, this is what I want to end up with, isn't it? That's my final volume. I want to end up with 100 milliliters. Okay, equation 1's done. Now equation 2. So we're going to attach the concentrations to each one, to each amount, each volume. it tells me that my first solution's 10% iodine. That's C1, so let's put that in right in front of the V1, right? So 10 V1. We're not going to put the percent sign in because it's assumed that it's in percent. And another that is 50% iodine. So that is the concentration of V2, right? So you guys need two equations, just like the coin problems. Equals, all right, now we have to put the concentration of what we want to end up with. We want to end up with what? 20%. C2, this is C final. Okay, so I'm going to put that, I like to put my concentrations in the front just for consistency. So 20, and then times my volumes. Okay, now please notice your volumes in the two equations don't ever change. Those should be identical. The only thing you've changed is you've added the concentration numbers in front. Now what you have is just, you have a nice system of equations. You can solve by substitution or elimination. I'll solve this first one by substitution. I would like to substitute for V1. So if I want to rewrite that first equation as V1 equals, how would I rewrite that? Can I get some help? Robel, how would I rewrite the first equation in terms of V1? Yes, 100 minus V2. Perfect. Great. We're going to substitute now into the second equation right here. So 10 times our expression for V1. And I'm going to ask somebody here in a second to distribute that for me. So if you want to do that, you can raise your hand. Could I get a volunteer to distribute the left side for me, please? Dylan, go ahead. Thank you, sir. Okay, now let's combine our V2s for 40. And let's subtract 1,000 from each side. And keep solving from here. So divide both sides by 40. And we have V2 equals, let's cross off 0 each place, and 100 divided by 4, 25. V2 equals 25. Just pause there. We're going to go back and label at the very end. But I want to go back and get V1. So let's use this rewritten equation here because this is exactly what we need, right? We need V1 and we have an equation that says V1 equals. So here we go, 100 minus V2, which is 25. V1 equals 75. Let's talk about labeling now. All right, let me resize my page here for a sec. Okay, when we label these, we need a couple of things to keep in mind. First, we need the units. So units here are in milliliters. You have to look at the text for that. So put milliliters on each. And then you don't just leave it like that. I need to know what's what. I don't know which one's your V1 and V2, so don't assume that I know. You have to tell me, what was my V1 from the text? Well, what did I do first? Oh, okay, I see that was the 10% iodine, right? That was the 10. So V1 is 75 mils of of the 10% concentration and tell me what is the substance. Okay, what is the substance? Iodine. I need all of that, okay? The units, milliliters, and then the concentration, and then what it is. And then the second one was, so V2 was the 50%. 25 mils of 50%, and then if it's a chemical, you can abbreviate if you know the abbreviation. Iodine is I think, hopefully. Let's do one more. A chemist has one solution that is 25% salt and 75% water, and another solution that is only 5% salt. How many milliliters of each should the chemist use to make 1,600 milliliters of a solution that is 15% salt? So it looks like this is like the last one. How many milliliters of each? Right, so we're solving for V1 and V2. All right, let's start to set this up. We need our quantity equation, and we don't know how much we're starting with, so just V1 plus V2. But do we know how much we want to end up with? What's my V final? My final volume, look at the last sentence, to make 1,600 milliliters. That's my final volume right there. V1 plus V2 equals 1,600. Okay, great. For our second equation, remember you need two because it's a system of equations. We're going to input let's go get our concentrations. The first solution is 25% salt, and another solution that is 5% salt. Okay, so that's concentration 1, concentration 2, and what's my final concentration? What do I want to end up with? 15% salt. So that's my final. Let's go input those. So for volume 1, 25%. So 25 V1. My second solution is 5%, so 5 V2. And I need to leave a little space here for my final concentration of 15. I like to put the concentrations first on all of them just for consistency. Times 1,600. All right, that's my setup. So quick question, you guys. Did you notice that I skipped the 75% water? Do you see that anywhere in our problem? You don't. The reason why is this is extra information. It's not needed in the problem. So the deal is, anytime you have a concentration, so look at all your C's. This must be the same, it has to be the same same ingredient, okay, or the same element. So salt plus salt equals salt. All right, what does that have to do with water? Nothing. That's extra information that's put in there as a distractor. It's kind of to trick you, not to be mean, but just so that you do a careful reading, okay? This is extra, but we want salt plus salt equals salt. The first solution is 25% salt. Great. It tells me what the rest of the solution's made of. I don't really care for this problem, right? I don't really care. So just ignore it. All right. So on this equation, this system of equations, I'm going to solve this one by elimination. But again, it's your choice. My goal is to eliminate the V2. So in order to do that, I'm going to multiply everything by -5. So when I rewrite that, I have, let's see, negative 5 V1 minus 5 V2 equals, and now I'm going to just, you guys, I'm going to show you this little trick. I'm not going to multiply this out. I'm just going to say it's negative 5 times 1600. I'm not putting that in my calculator. I'm not going to just say equals negative 90,000. I'm doing that for a reason. Okay, so now I'm solving this system down here, and I add them together. And let's see what we get. 25 minus 5, 20 for V1. My V2s are gone. Equals, now check this out. I'm going to suggest to you that this is 10 times 1600. 15 times 1600 minus 5 times 1600 is 10 1600. Okay, so this is kind of a little trick, a little algebra trick that I'm showing you. And it works because, see, I have the 1600 that's the same. Think of that as x. If I turn the 1600 into an x, would you agree with me that this would be true? 15x minus 5x equals 10x. And that's what I have here, equals 10x if 1600 is the x. Yes? All right, so that's just a little trick. Does it always work? No, but if you have the same number here, same multiple, you can do that. Now, if I have my calculator, I probably don't care, but if I'm doing this by hand, that's going to save me a little time. Plus, it's just a cool trick to know. So let's keep solving this. I have V1 equals, and let's do a little cancellation here. Let's cross off 0 here, 0 here. 2 into 160 is 80. And then you just have 80 times 10. That's cool. All right. That way I could just do that by hand. But, you know, if you have your calculator and if you make computation errors, then please do use it. Okay, V1 is 800. And so should we go ahead and label that now? We need units, milliliters. And my first solution was the one that was 25% salt. So 800 mils of 25% salt. Great. Okay, let's get our V2. Let's back substitute into our first equation, that one in blue there. So before we multiplied by negative 5, we had V1, which is 800, plus V2 equals 1600. Okay, so V2, subtract 800 from each side, or just think in your mind, what would I add to 800 to get 1600, right? So V2 is another 800, just by coincidence, it's the same. Okay, we write the units milliliters, and then what it is. That one was the 5% salt. And since there's so much on your page, please do make sure that you circle or box your answers, all right? That is chemical mixture problems.